Welcome, everyone. I'm Rick Wilson, the director of Scientia, and I'd like to thank you for attending today's Scientia lecture on the topic of facts. Well, the topic promises to be timely, exciting, and perhaps contentious. In the political realm, we've watched partisans bicker over the nature of what constitutes a fact, or in the current vernacular, what may be an alternate fact. In the scientific realm, we've seen conflict over which facts support conclusions about climate change. Scientia's colloquium series is going to look at facts from multiple perspectives and multiple disciplines. Well, today we're fortunate to have Richard Grandy, the Fred and Carolyn McManis Professor of Philosophy and Cognitive Sciences, speaking to us. His topic is theories about facts. Professor Grandy earned his PhD from Princeton University and has been at Rice since 1980. He is the most senior member of Scientia, although, as he points out to me, he's not the oldest. But he has been a member since 1982, which pushes him right up at the beginning of Scientia. We were having a discussion earlier who might be the oldest Scientia member, and I'm not going to reveal names at this point. It's not me. He's authored numerous articles in many different fields, including philosophy and cognitive science. That Professor Grandy reaches across disciplines is especially evident by the fact that he has received funding from both the National Science Foundation and the National Endowment for Humanities, which is a rare treat, or a rare double, what would be appropriate? A good double in baseball, I guess. Maybe a triple. So it's my pleasure, really, to introduce Dick Grandy, and I look forward to his talk. Dick?
It's a pleasure to be here today and have a chance to begin this series, which should be very interesting. A disclaimer, since I'm giving you the first talk, it would be improper for me to answer all the questions about facts today. So my goal is to provide some general observations, some framework, and to facilitate the discussion that I hope will happen starting after this lecture, continuing outside with refreshments, and continuing through the rest of the year. So, why facts? This is part of my abstract, for those of you who may have read it. We value facts for their authority. In science, we contrast facts with theories. Facts are the objective certain part, and theories are the more speculative part. In law, facts are contrasted with opinions. The facts are kind of what the decisions are based on. The opinions are the things that may influence them. If any of you are old enough or TV addicts enough to remember the Dragnet show, the most famous line in that was Joe Friday saying to various people he was interviewing, just the facts, man, just the facts. But one of the many areas I work in philosophy is philosophy of language. I started out working in philosophy of science and philosophy of mathematics because I was fascinated by how it's possible that we have such esoteric knowledge. And then I realized language had played an important role in that, so I wandered into philosophy of language. And language is very important, so how we talk about things influences how we think about things. So if you look at dictionaries, this is not all from one dictionary, it's from several, but we find at least 5 definitions of fact. One is something made or done. That may not be so familiar. It occurs in the phrase after the fact. That means after the thing was done or happened. Okay? Second is the most familiar sense, perhaps, something objective or true. What that thing is may be a little mysterious. Is it out in the world? Is it in language? Is it in us? Whatever. Number 3 is something believed to be true. Okay. Number 2 is out there. Number 3 is in here. It's my belief. I believe it to be a fact. I'm going to distinguish that from number 4, which is something presented as a fact. So if I may believe it, but it's different if Rick presents it. I have to decide whether I believe it and to decide whether to trust him. Okay? And finally, I was surprised to find this one. Okay, something which is undisputed. That one particularly, well, unsuccessful, I think, because suppose something is a fact in this sense, it's undisputed. Well, I can destroy that. If I dispute it, it's no longer a fact in this sense. Okay, and I think that's maybe part of the meaning that it has in the popular culture. I don't know. I'm not going to get too much further into that. I do want to talk a little bit about the origin of the word. I think that origins are important. I think that history of science is important for understanding science. History of mathematics is important for understanding mathematics. So fact comes from the Latin, facere, or facere, depending on your particular idiolect of Latin. And it means to do or to make. And so familiar words, manufacture, that means you're making something with your hands. A factory is some place that things are made. Factor is probably most commonly a verb. We factor equations, we factor numbers. But the things that you find when you factor the number that are themselves factors, they make up the number. That is, they're the prime elements. There's facilitate, to make something easier to do or accomplish. Remember I said in the beginning I'm going to facilitate this discussion. A word that's a little out of fashion now maybe is factotum. Factotum used to be a sort of a relatively high status word. This was someone who accomplished a lot of things, and various things. It's kind of gotten downgraded over the years because factotum became servant class. So they did a lot of things, but they were just kind of high-class servants. I don't know whether Siri counts as a factotum or not. You can think about that. And most importantly, faculty. Faculty are people who do or make something. What we do is teach or research. What we make, is knowledge, or something like that. Okay, back to my abstract. I said we can better grasp what facts are and why they have authority if we understand them as engineered rather than found or created. That was intended to give people at least a little bit of pause. That's probably not the way to think about facts. But it's not what I really thought. Okay? I didn't think engineering was quite the right word, but it was the best I could do at the time. I really think, myself, I think facts are manufactured. Now there's a problem with that. Okay? If I say, it's got bad connotations. So if I tell you my car was manufactured in Canada, that says nothing about its quality. I mean, maybe if I said it was made in Germany, that's a different judgment of quality, but there you're using the country. The process is not in doubt. Whereas if I say my facts were manufactured in Canada, those aren't facts. And they're no better if they were manufactured in Germany. So I didn't use the word manufactured because I could just see people quoting me everywhere. Facts are manufactured, right? Grandy says that. So I don't want to be quoted with that. So to avoid that, and since I don't have a better choice, I made up a word. Cognifactured. Manufactured are the things that are made by hand. Okay, with some thought. Things that are cognifactured are things that are made with our cognitive faculties. Some of them may be material, some may not. And I think it's helpful to think about how these compare to the things that are manufactured. So the elements of both manufacturing and cognifacturing are a material, something you use to make something, a goal, what you're trying to make it for, and a process. Manufacturing uses material to produce a physical object for a purpose. Okay, here's an example. Okay, this is a ladder. The function of this ladder had two functions. One was that you can go up that ladder and get to your cave dwelling. This is from Bandelier National Monument out in New Mexico. And the second function was once you were in your cave dwelling, you could pull that up and nobody else could get in and you could throw rocks down on your enemies. Here's a more complicated, sophisticated manufactured product. This had two functions. This had the function of storing wine and of being amusing or entertaining or aesthetic to look at. Okay? And one of the things I want to emphasize is that things that are manufactured are real. They exist, they persist over time. This goes back to about 1200 BC. It's from Crete. Here's something, it's not, we haven't finished manufacturing. Okay, how many people recognize this? Okay, if you don't recognize it, this is going to be the Gazelle School of Art, an extension of the Museum of Fine Art, Houston. It's going up on Montrose, about 3 blocks north of the intersection of Main. I live near there, so I go by it almost every day, and it's really fun to see them constructing it. An important comment about material. The ladder that I showed you, the material was not much processed. You take a piece of wood, you cut off the ends, you attach them together. Okay, so you're taking the material that's there. Those slabs of concrete are not something that people went out and found. Okay? Those were themselves manufactured for a purpose. So one of the points here is that in manufacturing, we have very sophisticated iterated processes. We make things that we use to make other things. In cognition, we make things that we use to make other things. And I'm going to partly talk about the tools that we make and how we use them. Okay, and we keep using this. We can talk about how the products, what properties the products have. They might be shoddy, they might be well made, poorly made, well designed, poorly designed, useful, useless. They have a purpose, and you have to think about that purpose. Are you trying to design a refrigerator that will be affordable? Lots of people can buy one and it will last for 7 years. Or are you trying to design a refrigerator that will last 30 years and will cost an arm and a leg? Your choice. Okay, so let's talk about the goal of cognition. This is my take on it. I'm sure that other people probably have somewhat different views. This is intended to be a fairly general, accessible notion. The idea is to take the overwhelming amount of information that comes in from the senses and memory, throw away most of it, keep the good stuff, and organize what's left in a useful way for planning or acting. So, when I'm looking at this audience, there are, probably 100 faces out there, and I can't begin to take in all that information. It's an enormous amount of information. Typical scene is like that. It's not divided into faces, but there's an enormous amount of information. Most of it is not important or relevant. We pay attention to certain things. We pay attention to the things that we think are important. Okay? One of the things that we pay attention to is motion. Okay? If I do that, even if your attention was wandering, you probably noticed I was doing that. Why do we pay attention to things that are moving? Well, of all the things out there, the things that are moving might be something that we can catch and eat. Okay? Or they might be something that's going to catch and eat us. Well, either way, we want to know what's going on out there. So, what are the sources of information? I'm going to broadly distinguish them into 3. One is perception. And by here I'm talking about direct perception, what's coming into my senses now and how I'm processing it. The second is memory, what I remember. I think we seriously underestimate how much of what we work with in memory. You may have perceived something yesterday, but that perception is gone. What you have now is the memory of it. Okay. You've probably all been to movies where the format is there were 6 characters who were present at this dinner or whatever the event was, and the movie has 6 parts, and each part is how a different one remembers it. Okay. When we remember, there are several issues. One is retrieving the relevant part, and the other is ignoring the parts that are irrelevant. So just as in perception, you don't want to retrieve everything in memory. You want to retrieve the helpful parts. And that can be very biased. The third source is, got various names depending on the quality. If it's in a courtroom under oath, it's testimony. Okay? If it's not, then it might be hearsay. If it's in a published in a professional journal, it's authority. If it's out in the hall, it's gossip. Okay? These are all different categorizations. But an enormous amount of our information comes in from other people. Now originally, of course, that comes from their perception, their memory, but what we get is from them. And so I want to talk about how these work and some of the issues. So this is the material that we work on when we're manufacturing things. Okay, so perception. We enhance our perception by using instruments, in many cases, which are themselves manufactured. Here's an interesting instrument. That's telescope. It is from the late 1600s. This is somewhat after Galileo. Galileo's original telescopes were about this long and about this size in diameter. This one is about 8 or 10 feet in diameter. You can tell by the size by the doorway there. Bigger telescopes were better. They were hitting the limit here, about 12 or 14 feet. They became unmanageable. We then invented the reflecting telescope, which is a more manageable size. So that's development of instruments. I'm largely working with simple instruments, historical instruments, because if I showed you the instruments that we use nowadays, they're mostly a black box. It's not very clear what they do without a lot of explanation, and part of which I can't do. Here's another instrument. In addition to visual information, we also need a sense of time. I think we are so familiar with time, calendars, scheduling, that we don't think about how important time is for organizing our lives. So for example, if the announcement had gone out that I would be talking today when the sun is at 58 degrees above the horizon, probably you wouldn't all be here right now. Okay? You'd be out there with your instruments trying to figure out exactly what was going on. So time helps us organize things. Time helps us all get to the same place so we can exchange the information, so it enhances other things. This is a rather old clock. It's in some ways better than modern clocks, aside from being more aesthetic. You may notice that it's a 24-hour clock, so that the numbers go all the way around. Because it says 12, but you can tell the AM is to the left, to your left, and the PM is to the right. It's less confusion that way, easier to read. The other thing, though, that this clock has is those dials in the middle. You might wonder what those are. Those are telling you where the planets are in the zodiac. Okay? Now that's very helpful. So in the morning, when you're organizing, you're getting your Excel spreadsheet out and planning your actions for the day, you look at this and you see that Mercury is in Sagittarius, and so it's a good day for doing this. We don't have that anymore. We lost it. This is also a reminder that science changes over time. Okay, what about enhancing memory? One obvious enhancement is language. Okay, if I can kind of repeat something to myself verbally, that helps me remember. If I can write it down, that's even better. Usually, we can do recordings, we can do drawings. Drawings are older than writing. They may be older than language. I don't know. I'll leave that to the linguists and the anthropologists. We can do photographs. We can do museums. All of those are ways of enhancing our memory. Remember, the vase that I showed you from Crete is now in a museum. It's now serving a new function, which is to help us remember and understand how that culture evolved. We can enhance perception and memory together. Okay, so this is not something you would see every day, most of you. And you don't have to remember it, because this is a part of a CAT scan. Okay, it's part of a brain. The advantage is the machine produces the image. It doesn't just produce a picture that the technician can look at, but an image that is permanent, or relatively permanent. So this is a doubly enhanced processing of information. It gives us information we wouldn't get otherwise, and it stores it for us. What about social source? Language obviously helps with social source. Writing helps. Print was a step forward. Being able to mass produce items was much better than writing manuscripts. The internet is a big step forward. If you think about, if we wanted to draw a graph of how rapidly information could be dispersed in the world for thousands and thousands of years, the fastest way to get the information somewhere else was to have somebody run it. Okay, that's how the original marathon was invented. It was the news of the valley. Then you get horses. Horses are quite a bit faster. You get things like the Pony Express. But if you do that graph, and it's relatively flat for thousands and thousands of years, and then in the early 1900s, or 1800s, you start getting telephone and telegraph. And then it's almost instantaneous around the world. So the graph looks like that. Okay, you can communicate much more faster, exponentially faster. If you look at how many people you can communicate with, it's a similar graph, just shifted 100 years. For a very long time, you could gradually increase how many people you could communicate with. But once you got the internet, it's multiplied by a factor of millions. So it's a very different world that we live in now. The socially sourced information is different. That's one of the things I think people will talk about later. Other social structures are journals and referees. That's supposed to help with the quality of the information. And then there's Wikipedia. Let me take a quick poll. Faculty, how many of you forbid your students to look at Wikipedia? That's good, you probably wouldn't succeed. How many people are sort of indifferent to whether the students look at Wikipedia? Okay, how many people encourage their students to look at Wikipedia? Okay, how many people require their students to look at Wikipedia? I do. Halfway through my course in, for example, in metaphysics, we've looked at a lot of concepts. The students have a sophisticated understanding. Their assignment then is to take each that takes one concept from the course, go to Wikipedia and look it up. Evaluate that article and grade it. Okay? They come back, the grades are anywhere from A to D minus. The Wikipedia average is somewhere in the B range. It's not bad for philosophy. I mean, it's probably better for philosophy than it is for more socially controversial topics. Okay, professional societies. We all know what professional societies look like, right? There's one. That's the Royal Society from back about 1700. It looks a lot like signing of the Declaration of Independence, but it's not. Okay, I've been talking about enhancing perception and memory. I haven't talked about enhancing reasoning, and the fact is, in my opinion, we've done a lot less by way of enhancing our reasoning than we have the other two. And that's going to be part of my topic for the rest of the session. I'm going to divide reasoning roughly into 4 categories here. This is just for my own talk here, my way of thinking about it. Logic, mathematics, science, and models. I'm not going to talk much at all about the nature of mathematics or science. Lots of you know much more about that than I do. I'm going to focus a little on models and a little bit on logic. Models because I think they're particularly important, and logic because that's my favorite subject. So there are physical models. They're globes and maps. There's the double helix model of the DNA that helped Watson and Crick figure out exactly what was the structure. They try to keep building a physical structure of it. Here's a model you probably haven't seen. This is a wind tunnel built by the Wright brothers. They not only built a model of the things they hoped would fly, they wanted a way of testing them, and so they invented the wind tunnel. And so this is a model of the environment in which the thing would fly. Okay? And this obviously saves a lot of time, a lot of material, a lot of injuries, because most of their designs didn't work. But it was a big part of their success that they devised this model. That's the physical model that helps with their design. There are mathematical models. We're all familiar with the solar system model of the atoms. That was kind of the way physicists first kind of came to theories of the atoms. There's Newton's equation for gravitational force, lots of others. There's weather models. Okay, we're fortunately or unfortunately familiar with these. I think one of the few good side effects, maybe the only one, of hurricanes is that people are paying more attention to models and they understand them better. Okay? Because if you look at this model, this is from about Friday night, you notice that the model, well, this is multiple models. Okay? And one of the things you see is the models disagree by about 150 miles as you go across Florida, where the hurricane is going to be. So that's the first fact. The models mostly agree. There's discussion if you go onto various sites as to whether the European model is better than some of the US models. The second thing you notice, pretty conspicuously at this point, is that they were pretty much all wrong by 150 miles. Okay, this is from, like I say, Friday night. Irma went up the west coast of Florida instead of the east coast. That was pretty disastrous for a lot of people. On the other hand, the other thing to take away from this is that it's actually pretty good. Okay, because 150 miles off is much better than we used to be able to do 10 or 20 years ago. I don't know about you, but I I didn't feel very good about our situation until Irma took instructions and actually turned right. And before that, you hope the models were right, but you weren't sure when that was going to happen. So as I say, I think it's going to help the general public be more sophisticated about models and understand the advantages and disadvantages of them. Okay, we have mental models. These are things we're probably not conscious of, though you can kind of get it into consciousness if you think about it. So there are roughly 3 models of how things work in a restaurant. One is you go in, it's a cafeteria, you choose your food, you put it on a tray, you pay for it, and you carry it to your table. Second model is the counter order. You go in, you order the food, and then depending on details, you sit down and either you go back to the counter or more likely you sit there and someone brings the food to you. Third model is the high-end restaurant. You go and you sit down, you look at the menu, and if it breaks down to 2. If there's alcohol there, then you have a long discussion in which you see who knows more about wine lists, and you order some wine. Or the alternative is you bring your own bottle. Okay? You get in trouble if you cross these models. Okay? So if you're in a sit-down restaurant and you go into the kitchen to get your food, you're not going to be welcome. Okay? And if you sit down in a cafeteria, you're not going to get any food. So we use these models all the time. We use these models in our interactions with people. So for example, we have a model of kind of what's the appropriate distance at which you have a conversation with someone. That differs. Okay? So I'm fine with Rick here. Okay? If Rick and I are Italians, then this is a good distance for the conversation. I once went various reasons. I was in Canada and then in Italy. The difference in the model of how many people can get on a bus is very impressive. In Canada, the bus was what we would describe as mostly full. In Italy, you can always get one more person in. Okay. Mental model of education. This is bringing it very close to home. The standard model is a lecture. Someone stands up front, presents information, the people out there absorb it. That's what I'm doing. There's relatively new, the lecture with flipped classroom, where the students see the lecture online or something like that, and they come to class prepared to discuss it. But you're still processing in roughly the same way. Then there's group work. This is something that happens, for example, in a design course where maybe, after a little instruction at the beginning, the students come in and they are working on their group on their problem, and they learn from one another. And there's evidence that for many things they learn better that way. You can mix that, of course, with the lecture model, mix them up. There's discovery learning, which is even less structured than group work. You kind of give the students some stuff to work with and they figure out what they want to do. Some evidence in some places, that's better. Okay? If you want details, see the people from Center for Teaching Excellence. They can tell you a lot more about it. So what we're doing here is partly thinking about thinking. We're trying to improve our reasoning by observing and reasoning about it. Okay, it's all we've got. But as I said, I think we've made more progress as a species at improving our perception and our memory than we have with our reasoning. Okay? So it sounds like a complicated task here, thinking about thinking, and it is. So here's a picture to help you with it. That's what we're trying to do. Now, our basic skills aren't great. Obviously we do pretty well most of the time, but there are issues with particular kinds of problems. So we have trouble with conditional sentences of the form if-then, negative statements. So here's an example. If I tell you we're going to have 4 cards on the table from a special deck, this is a deck that's constructed so that each card has either a positive integer on one side and a letter on the other. Okay, and here's a rule. Do these cards all fit a rule? Well, here's the rule. If one side has an even number, the other has a vowel. Okay, so if you need to check whether this rule is followed by those cards, and it costs you money to turn over cards, how many do you have to turn over to check the rule? Okay, I'll let you think a minute. Okay. Okay, so how many people think we need to turn the first one over? No, that's got a vowel on it. We're going to be okay. What about the second? No, we don't need to turn that over. Okay. What about the third? How many people think we need to turn that one over? Okay, good. How many people think that we need to turn the last one over? Okay, a few people, not many. Well, truth is, you need to turn over both the 8, obviously, and the D, because D is not a vowel, so you need to see what's on the other side. Okay. People don't do well at this. In many studies, the majority of students, that's the usual subjects, don't see that they need to check card D. Now, that's a pretty made-up, abstract situation. If you give them a more concrete situation, say, talking about a group of people and say, well, all the CPAs are wearing ties. That's a little more concrete, it makes a little sense. People do better at that. But a lot of them still miss it, a significant number. You might say, well, that's still not a real situation. It's an imaginary situation. It's sort of a real situation in one sense, but they're not in the situation. There's no consequence. Maybe they're just not paying attention. They don't care. They're subjects in an experiment. They're going to get their class credit, whatever they do. But in a 300-level mathematical logic class a few years ago, 30% of the students missed a concrete problem of this form. Okay? It was about SAT scores in majors. Okay? And this was at a very selective university. Okay? It's an unpublished study because I don't have permission to publish it, but you can probably figure out. So those were motivated people. They were getting exam points, which is better than money for right students. And they had studied, this was a couple weeks into the logic course, and they're at a 300 level. This isn't just freshmen. Okay. Here's another kind of problem that people have trouble with. Linda, and this is a standard example. I didn't choose it, so don't blame me for details. Linda has a BA in philosophy. What's the likelihood that Linda is a librarian? What's the likelihood that she's a librarian and a feminist? Well, in the way this was presented to subjects, these weren't next to one another. They were scattered through a series of similar questions. And people were asked to judge the probability of each. And in a significant number of cases, many subjects say the second is more probable. It's more probable that she's a librarian and a feminist. But that's impossible. Okay? The probability of being a librarian and a feminist has to be less than the probability of being a librarian. There can't be feminist librarians who aren't librarians. It's a theorem of mathematics. Okay? But people don't see that. Why? Well, because the one scenario calls up something a little more vivid. Okay? It's not just a bland librarian, it's somebody with political views, maybe. So it's kind of a clear image in our mind. And we reason sometimes with images. Well, but that's just unsophisticated subject. Someone did a similar study with MBA, it actually was MBA graduate students at Wharton. Okay, it's the top business school. And again, these questions were embedded in a much larger set of questions. They weren't next to one another. But one of the questions was, how much would you be willing to pay for a general one-year life insurance policy while you're working abroad? X dollars. How much would you be willing to pay for a one-year policy that would pay in case you died in a terrorist incident while working abroad? People would pay more for that. Even though, if you die in a terrorist incident, you died. And the first policy would pay off. Why? Well, because dying in a foreign country's got only kind of vague, for most of us, vague images, right? We're a terrorist incident. You can remember something that was in the news recently. You can even think about, which public place in Paris it would be. Okay. So objections. It's still not really happening. There's nothing at stake. They're not taking it seriously. A former Rice professor, Dan Osherson, took this seriously. He thought this was an illusion. He designed a study in which he basically took blue books. On each page to the blue book, there were 2 statements. And these were statements about real future events. The Astros will go to the World Series. The Astros will not win their division. And these were handed out to students, and students were to check one statement on each page. And after they finished, and students knew this was going to happen, he collected the booklets. He chose one at random. He then chose one page from one at random. So there's two statements here, and some students selected this statement rather than that one. If that statement turned out to be true, that student got $100. That's motivation. Okay? He got the same effect. His intent was to prove that the effect didn't exist, but in fact, he found it again in a very real way. So it's a very robust effect. You might say, well, this happens. Even the Wharton students aren't that sophisticated in statistics. If you embed these problems in a series of questions and you put a little time pressure on them, statistics professors make the same mistake. The only difference is that when you point students to the mistake, they have a tendency to say, oh, did they argue with you? It's not a mistake. Okay, and the statistics professors go. Okay, a little more mathematics. Mathematics can be helpful or tricky. So suppose I have a reliable crystal ball and I can see in the next 2 years, one of two things is going to happen in the stock market. Either it's going to go up 20% in 1 year and down 20% the next, or it's going to go down 20%. So, whoops, error. It's going to go down and then up. Okay, please correct that mentally. So either up and down or down and up, 20% each. Okay, got it? Now, unfortunately, I didn't buy the premium crystal ball, so I don't know which it is. And so what I want you to do is now think, are you going to be better off in the first or second scenario? Okay, so how do they say, up and down or down and up? How many people think you're better off in the first scenario? How many people think you're better off in the second scenario? How many people think you come out the same? You're right, you come out the same. It doesn't matter which order it happens. Okay. The question is, where are you? Okay, so if it does that, how many people think you are better off after it happens?
You say after 1 year.
No, 2 years.
No, when you go for the first, you say after 1 year.
No, that's okay. Where are you going to be better or worse off after 2 years? So are you going to be, if you get both of those, are you going to be better or worse off after the second year? How many people think you'll be better off? Equally, right back where you started. Worse off. Yeah, you're right, you're worse off. Either way, you're worse off. You end up with 96% of your original amount. Okay. This is why often advertisements for stock funds put things in percentages. They look better. Another problem is media often present percentages instead of absolute numbers, and those can be very misleading. Again, averages can be tricky. Part of what I'm talking about here is the fact that when we're cognitive-factoring things, it's not like we're taking simple perceptions like that's a chair. We're taking information about something like an average. Okay? So in any semester, this should be an easy one. How many courses receive course evaluations above the Rice mean? 50%, right? That's what a mean is. No. And I did this in spring 2012. I was department chair. I was pleased at how many of our courses were better than the mean. I did a little research and discovered that semester 60% of the courses were above the mean. And on instructor evaluations, 56% were above the mean. Okay, how is that possible? Well, means versus median matters. These are exact numbers. The median and mean is not the same because it's a skewed distribution, but how does it mean? How does it happen? Well, the Rice mean is an average calculated over all students in all classes counted equally. Okay? So suppose there are 10 courses with 100 students, they all get a rating of 3, they're big classes. 20 courses with 25 students rated 2, they're pretty good classes. 10 courses are small, they get rated 1. If you do the numbers, the Rice mean, which is divide the total evaluation numbers by the students, you get 2.4. Okay? So 30 of the 40 courses are better than average, the Rice mean. And half of the students are in below average courses. Okay. I didn't tell that to the dean when I wrote up my report about how good our courses were. Facts reside in a space between the mental realm and the independent realm. This is part of my abstract. This is one of the things that I think a lot of people balked at. What matters are our representations of facts and our representations of human construction. So I want to talk about an analogous phenomenon, which is colors. Most physicists, most philosophers, most ordinary educated folks know colors are not real, right? Physics tells us this color is not real. But look at any issue of nature or science. Most of the articles use color words. About 2 years ago, a lot of ordinary but educated folks had a very heated discussion online about the color of a specific dress. Some of you may even participated in that. Okay, I'm going to show you this picture before I tell you what it's about. Well, you know what it's about. It's beets and spinach, right? They're good for you. Nutritionists tell us that brightly colored vegetables are better for us. Well, if color isn't real, how can it be better for us? Okay. There's got to be something out there for, that's causing the color that's helping us with the nutrients. This is something that I came across by accident in the Chicago Art Institute. It was an exhibit on Renoir's true colors. And so this is art historians getting together with scientists and looking for true colors. So this is the current version of the Renoir painting. They looked at the pigments involved. Now what you want to pay attention to is not the face, which is where we would normally focus. Remember I said attention? Normally you see a picture, you look at the face. Look at the background. That's the background, that's the true color of the background as they constructed it. Even sophisticated cognitive psychologists will begin a talk by reminding us that colors aren't real. And then a few minutes later, they show us some clever experiments in which people see false colors. Well, how could there be false colors if they're all false? So something weird is going on there. Instead of just referring you to other people, let me do some of my own experiments here to try to underline the reality of colors, okay? Okay, what did you notice in that picture? A green car. What do you think you're going to remember about that picture? Green car. If I showed this to a bunch of other people, what are you going to predict they're going to see? Green car. Why is that if it's not something real out there? Okay, another one. This is called the Stroop Test. Which words are hard or uncomfortable to read? Okay. Kangaroo's not too tough. Brown's not tough. Green. Purple, oh, no, that looks green. What's going on here is that we tend to think, most of the time parts of our brain work together. But here's a case where we've got semantic information, the meaning of the word, conflicting with the color perception system, which is telling us, that second word is red. But the semantic information, no, that word is green. If you give people a long list of this, they're going to either be slower or make more mistakes in the color contrast cases. They also tend to get headaches after a while. So how do I resolve this? I'm going to go back to language and I'm going to say, well, color has at least 3 senses. And if we're careful about that, we can make sense of a lot of these. So I'm going to distinguish colors as properties of physical objects. So there's red apples out there, green cars, red beets. Colors as properties of light, red light. Okay? So if we had a bunch of red lights here, things would look differently. And finally, colors as properties of sensations. Those are things that are internal to us. So we have red after images if we look at a bright green picture. There's nothing out there that's red, but there's something that we have. So then we can say, carefully, the properties of the light interacting first with the physical object, so that's sense 1. Interacting with the properties of physical objects, sense 2, and then with the medium, and then with our visual system, produce the properties of the sensation in sense 3. So, and we understand, the people who study color vision understand this pretty well now. It took a long time to work it out. But it's an interaction between what's out there and the process of getting the information and then processing the information that comes in. So what I would suggest is this is kind of a model for how we might better understand facts. That they are partly determined by what's out there, but partly determined by how we process it. Now I've talked about the processing, what we have in our minds and our articles that we publish are the complex end product of what's out there. They're partly determined by our extended perceptual abilities, by our enhanced memories, and our extensive social information sources in our reasoning. Back to reasoning. A little bit more about that. We commonly distinguish two kinds of reasoning, deductive and inductive. The deductive deals with entailments, with certainty. Inductive deals with probabilities or likelihood. Deductive reasoning gives us secure conclusions. So if A and B entail C, more information can't change that. It also, if A and B entail C, it follows that A and B and D entail C, and anything else you care to add. But if A and B makes C probable, only probable, inductive logic, new information could change the outcome. It doesn't follow that A, B, and D make C probable. Okay, we're all familiar with this in practice. If the butler had motive and means, it may make it highly probable he committed the murder. But then, in the next chapter, or the next episode, we learn that the butler is right-handed, the murder was left-handed, and so the probability goes way down. More information, you lost the conclusion. So here's a problem. I've been trying to emphasize how we arrive at conclusions, that most of our conclusions are probable. Most of what we believe strongly is probable, not certain. If something's not certain and indisputable, a problem that I think, an issue that people probably discuss later in these series, the media try to be fair, and they present both sides equally. But that suggests that the evidence is 50-50. Okay? You very rarely find situations where they say, well, 98% of the experts say this. There are 2%, okay, and we're going to have give them a voice, but we're going to give them the two sides equal time. And I think that's a problem with the social dissemination of information. It's also the case that the media like to report something important. So they're going to report that there's evidence that increased activity in youth improves memory in older age. Now there is some evidence. They don't tell you that the increased activity was running on a wheel, and that the memory was whether you'd been shocked or not in the previous part of the experiment. And you might be able to guess from that fact that the subjects were rats. So there's some evidence, but that's not the way it's reported. So, the solution. Fact has too much connotation of certainty. It sounds as though that's just indisputable. Theory has too much connotation of mere speculation. We talk about that's just a theory. We don't have a single word for a theory which has been tested and is highly probable based on a great deal of reliable evidence gathered in an informed, relatively open-minded way. Okay. There's a lot of hedge in there, okay? It has to be relatively open-minded. You can't consider every crackpot, which means you have to decide who's a crackpot. So the homework problem for you is to come up with a word for that. Thank you.
We have time, a few minutes for questions, if there are any questions. I think you've left a lot of money here on the ground, which is great. Don't pick it up, I'll get it later. So, motion. Probably don't need one.
How does Plato's cave figure into this?
I'm sorry, what does?
Plato's cave figure out into your ideas of facts?
Well, in case you haven't had Philosophy 101, Plato's cave is a scenario where people are in a cave and they are seeing shadows on a wall cast by firelight behind them, and they take it that what they see there is reality. And they, of course, were wrong, because outside the cave there is a whole different world. Do we know that we aren't in a Plato's cave? No, I don't think we know that. But as we learn more and more about how we learn, there seems to be more and more evidence that we are in touch with in some ways, to some extent, to an external reality. Sorry, that's the best I can do at the moment.
when you were just coming up with the title for this discussion, theories about facts, is theories in this sense supposed to align with the connotation of like mere speculation, or is it more of a theory which has been tested and is highly probable based on the grade, etc., etc.?
Well, it actually is intended to include both ends. Okay, I mean, I'm trying to come up with something that's relatively well supported, but I intend the topic to include more speculative. To tell you the truth, the purpose of the title was really to give people some flavor of what the talk was going to be about and entice people to come. I tried the title out on the Scientia members, and it was very successful. There were about, 40 emails in 3 days, a couple of iterations. People said, no, it should be, facts about theories, or theories of facts and facts about theories, or theories of theories and facts. You can see how it proliferated. And that made me think that my title was fine, because if it generated that discussion, that's what I wanted to do. I mean, I'm trying to generate discussion. I hope it's a good discussion. I'm trying to guide it. I'm not trying to settle. I haven't, I presented a rough outline of how I think about facts, and I encourage you to think about that. I encourage you to improve on it.
Yeah, how would you analyze, on the basis of what you presented up there, the discomfort we have with the phrase alternative facts? Is that just something that doesn't fit the criterion of the conjunction that you're looking for a single word for?
I think not. I mean, it even depends there on exactly how you understand alternative facts. Okay, I mean, in some cases, I think this is covering things which we would regard as facts, but perhaps, or at least having some evidential base on some experts. But, we think those are misleading or whatever. Now, there's also the alternative fact, which is sort of closer to counterfeit. Something that's just made up to mislead people. That doesn't fit what I have in mind here. But that's part of why I say, when you're looking at all the evidence, and some of our evidence is inevitably social, it's what other people say, you have to decide to what extent are you open-minded, and to what extent do you have to draw the line and say, no, that's not an opinion I need to take seriously. I mean, being a philosopher of science and mathematics, I, over the years, have a number of times been approached by someone in the administration because there's some potential donor who has a new theory of physics, fundamental physics, going to revise physics, right? And the physics department won't give them the time of day because they think they're a crackpot. But the administration sort of likes the size of the checkbook, and so they would like someone who is patient and knows some science to discuss with those people their views. So I get some free lunches out of it. Anyway, the universities attract that. You get people who have. I get probably at least one email a week from somebody who's read my website and says, okay, you do philosophy of science, I have this scientific theory, no one will listen to me, can you help me? Usually not. But on the other hand, if you look at the history of science, I mean, there are certainly many cases where someone came from another discipline, they were not an expert in that area, but made important contributions. So you have to be really kind of careful in that, and there's no guarantees. One of the things that I think is a little problematic in the way we often teach science in science textbooks is that what's presented in there is what philosophers used to call a rational reconstruction of science. And so, we don't mention the fact that Newton probably spent half his time doing experiments in alchemy. We don't study his alchemical texts. We, tell people that Galileo went up the Tower of Pisa to prove his theory. He didn't. Actually, it was one of his opponents who went up to the Tower of Pisa and dropped 2 weights, and you know what? The heavier one hit the ground first. But you know, and part of the problem is, you know, I think we sometimes present this totally sanitized notion of science in which we've never been wrong. It's all cumulative and good. And if people get disconnected from that, they see uneven evidence against it, then they become suspicious of the whole enterprise. And I think it's much better if we're upfront and say, it's not certain. And and it's a very sophisticated idea of evidence, of being pretty sure of something, but not certain. I didn't, you know, I could have alternatively given this talk on evidence, because that's kind of a core. Where does our evidence come from? How do we evaluate it? Kristen?
Yes, you mentioned toward the end, we want to be able to consider a theory probabilistically, but in order to do that, we might have to draw a line and say everyone on the other side of the line is a crackpot. But in terms of being able to figure out this probability and figuring out where to draw these lines, I'm wondering how you think of these probabilities. How objective are these? Because if I'm thinking, how do I draw the line between who's the crackpot and who's not, that's going to depend on my probably a lot of my background theory. And so, like, if I come from, say, purely for the sake of argument, I come from a community of right-wing Christian fundamentalists. I might, oh yeah, sure, I believe there are crackpots. These are just a totally different group of people. So, like, are these probabilities objective? Can these be applied across communities? And if not, are we to see this as these probabilities as indexed to particular communities?
Well, a very excellent and very complicated question. There's an ongoing development in statistics. I don't know if we're going to have a talk on that later this year or not. It's called the Bayesian view of probability. And historically, probabilities have been seen as objective. They are the long-run frequency. Now, that doesn't make a lot of sense. So we want to evaluate whether the theory of relativity is right. So we look at all the theories like that in the history of science and see how many turned out to be right. Well, there weren't any others. It's not a very big sample. So the alternative is to say, let's not go to communities, but I assign my own probabilities to things. You assign probabilities, your own probabilities to those things. And we then use what's called Bayes' theorem. And if you and I can agree that if this statement is true, then this is going to happen, and it hasn't been tested yet, and we go out and we agree that it happened or didn't happen, and we apply Bayes' theorem to update our probabilities get closer together. And if we do that often enough, our probabilities converge. Converge in the mathematical sense in that they approach one another. Doesn't mean they're ever going to be exact. But given enough input, they will approach one another. And that's how I think about it. So we need to take, your two hypothetical communities, and now the hard part, of course, is to get them to agree on what are the consequences of what they believe. And then follow that out, do the experiments, gather the evidence, get people to update their probabilities based on that. Even if you've got, the fact is we don't have direct insight into probabilities even in the kind of long run sense. We have information about it. And we should probably sometimes update that. So, for example, if you think that a certain event, let's call it a 500-year flood, has a probability of happening once in 500 years, and it happened this year, and last year, and the year before, then you better update your probability. I hope people do.
Thank you very much. This is